Okay, so that recall that values of x when y equals 0 can be referred to as x-intercepts if they're real. Okay, x-intercepts have to be real numbers, but they can also be referred to as zeros, and zeros don't have to be real. They could be imaginary as well, and they could be referred to as roots. And so our focus here is solving for x, and so part A, part B ask for finding the roots or finding the zeros, same thing. And so the idea is we need to set y equal to 0 on both of those to do this. And on A, it's written in a different notation. We call this function notation, but f of x represents your output or your y values. And so we'd set that equal to 0. Okay. And what I want you to do, I'm going to give you a series of problems, and you get to pick what method you want to use on those problems. But I really strongly encourage you to try factoring first for two reasons. One, factoring is often easier. But two, factoring is the most important for you to understand. So even if you're like, you know what, I like the just one method, I'm just going to plug everything into the quadratic formula. Yeah, you can get the answer that way. But don't avoid factoring. You want to master it, right? So if it factors, factor it. But not everything will factor. So if it doesn't factor, then you have the choice. Pick your favorite. Go to either completing the square or quadratic formula. You get to choose, okay? So on this one, we're going to try factoring it. When you factor, if you have any factoring problem, ask yourself, can you factor something out of all of it? I mean, the 6, the 8, and the 30, they're all divisible by 2, so I could factor out of 2. I'm left with x squared minus 4x minus 15. And then I'm going to try to factor the trinomial by looking for two numbers whose product is negative 15 and whose sum is negative 4. Yeah. I'm sorry. I made a mistake here. Let me fix that. Thank you. Should be 2 times 3x squared. So we want two numbers whose sum is negative 4, but whose product is 3 times negative 15, which is negative 45. So can we come up with two numbers that meet that criteria? What? Negative 9, positive 5. So then 0 is going to equal 2. Leave that 2 there. And I'm going to now expand this to 4 terms. So 3x squared minus 9x plus 5x minus 15. And once you have the 4 terms, you factor by grouping. So out of the first 2 terms in there, I'm going to factor out a 3x. And I'm left with an x minus 3. Out of the last 2 terms, I'm going to factor out a 5. I'm left with an x minus 3 again. And then one more time, I could factor an x minus 3 out of both those pieces and get 0 is equal to 2 times x minus 3 times 3x plus 5. So now it's fully factored. I have 3 factors. I have a 2, x minus 3, and a 3x plus 5. Your answers are in the factors that have the variables. So that 2 is not going to give you any answer that you want. But this x minus 3, I'm going to set that equal to 0 and solve and get x equals 3. That's one of your answers or one of your roots. And the other comes from the 3x plus 5. Set that equal to 0 and solve. And you get x is negative 5 over 3. So those are your two roots. Okay, so again, that factor, that 2 out in front, you don't set that equal to 0. You just leave that there, kind of ignore it. Okay, it's not very helpful in terms of solving. All right, part B asks us to find the zeros, and zeros are the same thing as roots. And so you start off by setting y equal to 0, and you look to see, does it factor? Does this one factor? Yeah, it's a different kind of factoring. Here we have a difference, a minus sign between two perfect squares. And so there's a pattern to how these factor. You take the square root of each. You get x and a 9. And so this is going to factor to x plus 9 times x minus 9. And so if x plus 9 is 0, we get x equals negative 9. If x minus 9 equals 0, then we're going to get x equals 9. Okay. This is one that solving by completing the square may be a quicker method too, that you add 81 to both sides and take the square root and you get plus or minus 9. But practice that factoring. It's a good thing for you to get a good handle on that, okay? Part C. So part C and D, notice here it's just saying solve for x. We got these equations. And if you want to solve for x, the first thing you need to do is let your equation equal 0. So make your quadratic equal 0. I'm going to write that down here. Okay. Make sure the quadratic is equal to 0 before solving. So on part C, because here's a typical mistake that someone would do. X squared equals 10x. Oh, I'm going to divide both sides by x, and I get x equals 10. Oh yeah, I got my answer. Typical mistake. Yeah, it's kind of right, but kind of wrong. They got one of the two answers. There's another answer out there as well. Anybody know what the other one is? What is it? Not minus 10. So here's a hint. When can you divide by x? If x is not 0, right? Because you can't divide by 0. So if x is not 0, then 10's your answer. But x could be 0 as well. And if you plug in 0, you get 0 equals 0, and that's your other answer. So to catch both answers, do what I said. Make it equal to 0 first. So you got x squared equals 10x. And the way I'm going to make the right side equal to 0 is I'm going to subtract 10x from both sides of the equation. I get x squared minus 10x is equal to 0. And then I'm going to try to factor that. Does this factor? Yeah, and it's another kind of factoring out the GCF. It's the most basic kind of factoring. You can divide them both by x, or factor an x out. You get x times x minus 10. And you got two factors. So you set x equal to 0. There's one of your answers. You set x minus 10 equal to 0. You got your second one, x equals 10. Last one, part D, that I'm going to do with you. Again, I want to make one side equal to 0, so I'm going to subtract 63 from both sides, and I'm going to add 5x to both sides. So we get 0 on the right-hand side, and on the left-hand side we get 2x squared plus 5x minus 63 is equal to 0. Think that thing's going to factor? Why don't you try it? I'm going to pause here, see if it factors. If it doesn't factor, then pick another method. Okay, so if it doesn't work, try a different method. So when you're trying to factor this, you're asking the questions, can we come up with two numbers whose product is 2 times negative 63, which is negative 126, and whose sum is 5. And first, this is not an easy thing to come up with because 126 is a bigger number. And when you have bigger numbers, it's always good to break them down to the prime factorization. So we know 126 is 2 times 63. I'm just going to work with positive numbers right now. And 63 is 9 times 7. 9 is 3 times 3. So 126 is 2 times 3 times 3 times 7. Okay. And so you just try matching different things up. We're looking to create a product of two numbers, and we want their difference to be 5. Right? One positive, one negative, we add them together. Are you seeing it? What? 9 and 14 have a difference of 5. And so this is negative 9 times positive 14. Is what you're saying? All right. So that by breaking it down, it's easier to find that because not maybe to know 9 times 14 is 126. So now we found it. So we can split this up to 2x squared minus 9x plus 14x minus 63 is equal to 0. First two terms, I could factor out just an x. The last two terms, I could factor out a 7. And then I could factor out the 2x minus 9. I'm left with x plus 7. So now it's factored. And now I can solve. So when 2x minus 9 is 0, 2x is equal to 9. So x is 9 over 2. When x plus 7 is 0, we get x is negative 7. Okay. So all my examples did factor. and but the ones you're seeing, they may not all factor. But you try factoring first. And again, if it doesn't factor, then fall back on either completing the square or quadratic formula. Okay.